Okay, in 5.2, we're going to continue writing linear equations, but this time it's going to be that we're going to be given the slope and a point. So you're going to be excited here because if we're given a point, we're going to be using an x and a y coordinate. And so our x and our y are finally going to be filled in on our slope-intercept equation. So the slope-intercept equation is y equals mx plus p. And in this lesson, you will learn to write an equation of a line when given its slope and any point on the line. And that's finally where that x and y in the equation are going to come from. Okay, not the y-intercept, but a point, a coordinate point x and y. So the first example gives us the equation of the line that passes through the point 6, -3 and has a slope of -1. So we're going to go ahead and we're going to substitute in what we know. So I'm going to just write the formula here. So we have that to refer to. So that's our formula for slope-intercept. So I know the slope is -2, so I'm going to go ahead and put that in there. But this time I know a point. And in the point, I know the x and the y value. So I'm going to go ahead and substitute those in. So the x is going to be 6. I know nothing about the y-intercept, so I'm going to leave that as b. But I do know my y in the coordinate point is a -3. So let me just review that again. Slope was given to us, but our new information has been the x and the y coordinate points, and those are coming from, the x is coming from there, and the y came from there. All right, so now that we have that information, we can go ahead and to write an equation in slope-intercept form, we do need to know what the y-intercept is going to be, but now we have a simple algebraic equation. So let's go ahead and see if we can simplify this. So -3 equals -2 times 6 is going to be -12 plus b. B is my y-intercept, so I need to solve for that. So I'm going to go ahead and add 12. Oh, that's not very legible. I apologize for that. There's been some updates and we've had a little bit of problems with them. Add 12 to both sides. And so -3 plus a very illegible 12 will give me 9. The 12s are going to cancel out. And so my y-intercept happens to be at 9. So our initial question was write it in slope-intercept form. So I'm going to go ahead and do that. So I'm going to have y equals, go back up, my slope is a -2, -2x, and then that's a +9, so +9. Now I do have the graph of this equation, so let me see if I can highlight and scoot this over. Oh, it's not going to happen that way. Let me move the graph up maybe. That looks like it's the simpler way to go ahead and do this. And then I will reveal the graph. And to graph anything, we need to know the slope and the y-intercept. So the y-intercept's at 0, 9. My slope is at -2. So if I go down 2 and over 1, I'm going to find my points on the line. And then we were given 6, -3. So let's go ahead and see how we did. If we go over 6 and down 3, yes, that point lands on our linear equation that we graphed from slope-intercept. Moving on, it says writing an equation of a line given its slope and a point. First, we need to find the y-intercept. That was algebraically. And then we need to write the equation of the line. So if this time we're going to be talking about parallel lines. And if you remember when we were talking about parallel lines, we talked about parallel lines have the same slope. their slopes are going to be the same. That's the information we know about them. So it says two non-vertical lines are parallel if and only if they have the same slope. Write an equation of a line that is parallel to the line y equals 2/3 x minus 2 and passes through the point -2, 1. So just like the example before, we're given a point and we are given the slope. We need to look for that slope a little bit more, but knowing that parallel lines have the same slope, we can find that the slope of our new line is going to be 2/3. So I'm going to go ahead and I'm going to do the same thing I did on the last one. I'm going to go ahead and my y in my coordinate point here is 1. So I'm going to say 1 equals, I'm going to put in my slope, 2/3. I'm going to go ahead and apply, or I'm sorry, not apply, but substitute in my x, which is a -2. And then I do not know my y-intercept yet. So I'm going to just put plus b. Now I want to solve for b. So I'm going to go ahead and simplify the equation. I have 1 equals a -4/3 plus b. Oh, we need to do some fraction. This time we're going to subtract a -4/3 from both sides. So if I subtract -4/3, that would be that I'm going to actually add 4/3. So I'm going to end up with 7/3 equals b. So writing it in slope-intercept form then, I would write y equals, and my slope we already found out is 2/3, and top of my numbers is not writing very well again. Let's go ahead and undo some of those and see. Try writing them one more time. Y equals, and let's try it one more time. Oh, there we got a better 2/3 x, and then my b is going to be plus 7/3, or if you wanted to, you can change that to 2 1/3. Let's see how we did when we reveal the graph and see if that's going to support it. So they went ahead and they graphed the first line, y equals 2/3 x minus 2, which is the blue line. Then when we graph our line, which is the red line, we're going to get y equals 2/3 plus 7/3. You notice our y-intercept is marked and our -2.1. I'm sorry, our -2, 1 for the other point is graphed. And you can see that those lines are parallel. So we're going to move on to some real life models, and we're going to talk about vacation trips. So between 1985 and 1995, the number of vacation trips in the United States taken by United States residents increased by 26 million per year. Again, you see per, so you know that's going to be a rate, and a rate is going to be your slope. In 1993, United States residents went on 740 million vacations within the United States. That's our constant term. So when we go ahead and we try to write this equation, we're going to write the number of, it says write a linear equation that models the number of vacation trips in millions in terms of year t, and let t be the number of years since 1985. So we're going to go ahead and we're going to put in all the information that we know. So if you look at the information here, we have that in, we'll say 8 years. So in 8 years, it was 740, because where are we getting that? It was 740 million trips, and that was in 1993. So the time that passed from 1985 to 1983 was 8 years. So that is now a coordinate point. So the time was x, and if you thought about that in or on a graph, you would think time is the x-axis, y is how many million vacations, and so we have the coordinate point 8 and then 740. So we're going to do the same thing we have been doing. We're going to write our rate. Our rate is 26. So our equation is going to look like this. Whoops. Y equals, I'm not sure what you see with that, but that's when I'm changing the size instead of writing. Y equals, and our rate is 26. Our time, we're not sure of yet for our initial equation. Having some trouble with the screen again, I apologize. Oh, apparently I want to do some Skyping. Okay, 26t, at least we're writing again, plus b, and our b is going to be 532. I'm sorry, we skipped some here. You don't know 532 yet. So let me get rid of that. All the technical problems, it skipped ahead. I apologize again. All right, so let's go ahead and do some figuring with the information we know so that we can see where I got that information. So we're going to go ahead and we're going to put in the year, y, which is 740, and 740 equals the rate, which we said was 26, and the time, and that's going to be that there were 8 years, or our x coordinate point, plus b. So we need to solve for b. And so I'm going to do just a little shortcut here. 26 times 8 is going to be 208. So when I subtract 208 from both sides, I get my b equals, and my b equals 532. So if I reveal, I think I have the graph on the next page, I do. So if I reveal, plugging in what I jumped ahead with before, if I reveal the graph, you're going to see, again, that the graph of the line, I needed to put it in slope-intercept form, but I can see that my graph does, in fact, go through both of the coordinate points that we were given the information in the story problems. And that concludes 5.2, I believe. Yes, that's the conclusion of 5.2. Let's see if we can quit recording.